Hello, good morning, everyone. Any questions if you have from previous classes? Yes, go ahead. बट लाइटर के लिए हम कर सकते हैं, बट क्यों करेंगे हम? क्वेश्चन ये है कि LVM3 हम हेवियर लॉन्चेस के लिए यूज़ करते हैं. कैन वी यूज़ इट फॉर लाइटर लॉन्चेस? वी कैन ऑफ कोर्स डू दैट फॉर लाइटर लॉन्चेस. आई हैव अ ट्रक, आई कैन पुट लॉट ऑफ थिंग्स देयर, और मैं खाली ट्रक में भी लेके जा सकता हूँ मैं, बट कॉस्ट इफेक्टिव नहीं होगा. अगर क्वेश्चन ये है कि वी कैन ओनली यूज इट फॉर हेवियर लॉन्चेस, then that will be a wrong statement. If the statement is that we use it for heavier launches, then that will be correct statement, right? So liquid velocity trimming module simply means that the question is about SSLV का जो final stage है. So we are not calling it as a separate stage because it is not a separate engine with separate arrangement. It's not a stage which separates after third stage. So hence I have not called it as part of some separate stage. But at the end of the rocket stage, you still do use liquid fuel, so that if we need to, let's say, control the velocity, if we need to control the thrust, we can use that velocity trimming module. Velocity trimming का मतलब यहाँ पे ये है that we want to control the velocity, and it's easier to do that with the help of liquid fuel, which I was talking in the last class. Okay, tidal force, ठीक है. We will try to understand the concept of tidal force also. Any other question? नहीं, फिक्स्ड पाथ नहीं होता का क्या मतलब है? When you say कि लो अर्थ ऑर्बिट में फिक्स्ड पाथ नहीं होता, उसका क्या मतलब है? ओके, हम बार बार हम दो चीज़ों को कंफ्यूज हम जक्स्टापोज क्यों कर रहे हैं? ये मैंने पहले क्लास में ही बोला था कि ये दो चीज़ों को हमको जक्स्टापोज नहीं करना है. When I talked about that we get in equatorial orbit, we get help from Earth's rotation, I was talking about rocket. That's it. I was not talking about satellite. वो सैटेलाइट क्या है वो छोड़ दो. सैटेलाइट को हमको पोलर ऑर्बिट में लॉन्च करना है, बट वंस आई लॉन्च अ सैटेलाइट देन इट डजंट मैटर. अर्थ का रोटेशन से सैटेलाइट के मोशन पे फर्क नहीं पड़ेगा. अर्थ के रोटेशन का फर्क पड़ेगा कि कैन दिस सैटेलाइट ऑब्जर्व ऑल पॉइंट्स ऑन अर्थ. सो यस, इन पोलर ऑर्बिट्स इट कैन डू दैट, इट कैन नॉट डू दैट इन इक्वेटोरियल ऑर्बिट. जियोस्टेशनरी का इनहेरेंट बेनिफिट ये है that a satellite seem to be fixed with respect to a point on equator, which basically means that think of Earth. This is Earth, and I have a satellite here, and anywhere, any radio station here, I can maintain a line of communication. That is the benefit of geostationary. That's it, nothing else. उसके अलावा जो earlier point था वो खुद में एक अलग point है, उसका इससे relation नहीं है. You had a question. Somebody had a question here. We will talk about magnetic levitation in later classes. We haven't हमने कोई topic discuss ही नहीं करा magnetic levitation से. So, okay, we will talk about magnetic levitation in later classes. What is magnetic levitation? Sorry? We'll discuss about telemetry also in later classes. Yes, go ahead. Okay, ठीक है. Understand your question. The question is asking is that our goal in sun synchronous orbit was that we want to launch a satellite so that we maintain a fixed orientation with respect to sun. It is in same light, but the question is that what if the climate is not good? What if it is cloudy or something like that? So remember, we are talking about 5-10 years. So yes, there will be days where there will be some local weather condition will not be very suitable, and that's fine. But it's not about that every time it reaches. There will be some disturbances, some local disturbances will be there, but a comparison, we are talking about a comparison across 5-10 years. So most of our data still will be in the same amount of lighting and shadow, okay? I asked a question in the last. हाँ जी, go ahead. Effect of eccentricity on the shape of the orbit. So if eccentricity, आपने eccentricity पढ़ा है, ellipse का eccentricity पढ़ा है आपने 11th 12th में. In the last class I told you about uh, that how some ellipse, I used the word ellipticity. So some ellipse are much more ellipse and some ellipse are closer to circle, right? So effect of eccentricity is very simple. That eccentricity अगर 0 है, so it becomes circle. अगर eccentricity 1 के बहुत पास में है, तो it becomes very much closer to ellipse. So think of a highly eccentric orbit और जिसका eccentricity 0 के बहुत पास में हो, उसका बस ये होगा कि जो पेरिजी और एपोजी का डिफरेंस होगा वो बहुत ज़्यादा होगा, राइट? सो पेरिजी एपोजी का डिफरेंस जो होगा कम होगा, एंड जितना एक के पास होंगे पेरिजी एपोजी, तो इस केस में बस यही होगा. जनरली जो ऑर्बिट्स होंगे दे विल बी क्लोजर टू जो E इज इक्वल टू 0 है उसके आसपास होंगे. सिंपल, राइट? We can say that. Yeah, that's a very good point actually. They do not have to. So the question is that can we say that sun synchronous orbit follow the circle of illumination on Earth? So first let me tell you about circle of illumination. This is sun. Half of the Earth is basically witnessing sunlight. Half of the Earth is not witnessing sunlight. So the point on Earth or the circle on Earth, the point on Earth where this part of the Earth there is day, this part of the Earth there is night. So that circle is called circle of illumination. And circle of illumination clearly will change because remember Earth is rotating on its axis. So in many cases we try to launch a satellite in sun synchronous orbit that it comes very close to circle of illumination. Uska benefit ye hoga that my satellite will not have to worry about its power source. जो satellite के solar panels हैं, those solar panels always are receiving sunlight from sun. They do not have to worry about that they might lose the power source. So yes, we can plan sun synchronous orbit in a way that it is revolving above circle of illumination. It will not be that exactly all the time you are at circle of illumination, but more or less you can be very close to circle of illumination. Circle of illumination, I will repeat, it divides Earth into two parts, the part which is witnessing day and the part which is witnessing night. Okay, so in the last class I gave you a homework. I asked you a question about temperature, that why do we have zero minimum temperature? The 0 Kelvin hai, that so-called minus 273 degrees Celsius. That why we have a minimum temperature? Yes. Not the volume, but the kinetic energy part. Kinetic energy 0 से कम नहीं हो सकता. Simple. जो हमारा आंसर है इसका. Anyway, so let me. I asked another question also, that what does temperature represent quantitatively, right? जैसे हम बोलते हैं कि टेम्परेचर 30 डिग्री सेल्सियस है या 50 डिग्री सेल्सियस है, 100 डिग्री सेल्सियस है. व्हाट डज दैट मीन? नाउ हमने एक पढ़ रखा है कि चलो थर्मोमीटर बता रहा है, बट थर्मोमीटर बता क्या रहा है? व्हेन थर्मोमीटर इज सेइंग 100 डिग्री सेल्सियस, देन व्हाट इट इज टेलिंग यू? What is the quantitative definition of temperature? So turns out temperature is a type of phenomena we call emergent phenomena. Emergent phenomena का मतलब होता है that for an individual electron I cannot define temperature. For an individual proton I cannot define temperature. Or for one atom, for one molecule, temperature does not make sense. But when many atoms and molecules come together and they form matter into any state, solid, liquid, gas, or even plasma for that matter. I'll be talking about plasma in today's class itself. So matter in any stage, then turns out that, let's say, we may think that these water molecules, there are trillions of water molecules here, and we may think that they do not have, they are like lying down without any type of motion. And we are so wrong in that assertion. Turns out that these molecules here, these atoms and molecules, they have so many different types of motions. We cannot see that, but we can experiment it, in fact, by the way. We can do that, we can experiment even at macro scale. So these atoms and molecules, they are, for example, rotating, they're oscillating, they're vibrating. All the time they are moving. And every type of movement has its own kinetic energy. Remember your class 9th classes? Class 9th का हमने क्या पढ़ा था? कि whenever objects are moving, there is a kinetic energy. Kinetic energy का जो सबसे simple formula हमने क्या पढ़ा था? Half mv square. 1 by 2 multiplied by mass multiplied by square of the speed. That is what kinetic energy is. So that is when objects are moving in some sort of circular motion or straight line motion. But when objects are rotating, it will not be half mv square, it will be half I omega square. Whatever formula of kinetic energy is, it will be half multiplied by a parameter which will always be positive. जैसे mass is always positive. And it will be a parameter जिसका हमको square लेना है, and squares will always be positive, right? So kinetic energy का कोई भी form हो, it will always be positive. So what does temperature represent? When I keep increasing the temperature, the molecules and atoms, they start vibrating more, rotating more, they start moving around much more. So temperature essentially represents kinetic energy of an average molecule. I asked a question that what does temperature represent? Temperature essentially represents the average kinetic energy of one molecule. Why I'm using the word average? Because not all molecules have same kinetic energy. And that makes a lot of sense, because think about it, when you put water on a gas stove, ऐसा तो है नहीं कि सारा का सारा पानी एक साथ वेपराइज हो जाता है. थोड़ा सा पानी वेपराइज होगा, फिर थोड़ा और होगा, फिर थोड़ा और होगा. You have to put that water on a gas stove for some time so that all of the water vaporizes. अगर सारे water molecule का energy exactly same होता, and you are providing some energy you are increasing the energy, all of that water would have vaporized simultaneously, which does not happen. So clearly the water sample you have chosen, the water molecules have different amount of energy. So hence I'm taking the average energy. Water molecules can have lot of different amount of energy, but I am only focusing upon the average energy. So temperature is proportional to the average energy of one molecule in a particular sample. However, temperature has no meaning when I only talk about one molecule का temperature का मतलब नहीं है. When I talk about many molecules, trillions of them forming a matter, चाहे वो solid हो, liquid हो, gas हो, and that all of that that matter and all of those molecules, turns out they're not at rest all the time, they're moving, rotating, oscillating, and all of that is essentially kinetic energy. So temperature is proportional to the average kinetic energy of a molecule in a sample. Now we know that why there will be a minimum temperature. If you keep reducing the temperature at minus 10 degrees Celsius, जो objects का, जो molecules का kinetic energy होगा वो कम होते चले जाएगा. जो इनका rotation है, revolution है, oscillation है, ये सब कम होते चले जाएगा. Keep doing that, it will start coming to zero, and there will be a temperature where all of the molecular motion ceases to exist. There is no molecular motion anymore. उससे नीचे हम नहीं जा सकते. Kinetic energy का जो minimum value है, remember half mv square. Mass is always positive, v square is always positive. So minimum value is when v becomes zero, which is basically zero. So we only have zero kinetic energy as the minimum value, and that zero kinetic energy we arrive or we reach when the temperature reaches at minus 273 degrees Celsius. So that is why you do not have any less temperature than that. You do not have temperature below minus 273 degrees Celsius. One more question I asked. In fact, I'm going to answer this question, but first let me start today's class with Aditya L1 mission. Give this heading. Aditya, in fact, not Aditya L1 mission directly. I should briefly tell you about some of the significant missions of ISRO in the field of astronomy. Now we are done with satellites, their applications, everything. What is ISRO doing in the field of astronomy so that we get to enhance our knowledge about, let's say, Earth or Moon or solar system, or for that matter, we get to enhance knowledge of universe itself. So many space agencies launch projects in this particular direction, and even ISRO has done. ISRO has launched many projects in the past, and some of the projects have been actually globally recognized because ISRO is known for its cost effectiveness. Jaise, if I have to talk about some of the past missions of ISRO in the field of astronomy, I'm briefly going to write their name, and in one line I will explain what they aimed to achieve. So I will start with these 4 missions. I'm not going to make you write anything about those missions. If you want to write up, खुद से running notes बना सकते हो. I do not expect a question in from these topics. There have been questions from these topics in past year examination when they were in news a lot. Chandrayaan 1, that was launched by ISRO in 2008. And Chandrayaan 1 was only an orbiter mission. तो जब भी interplanetary missions हो या lunar missions हो, interplanetary मतलब we are sending something to some other planet, or even it is a lunar mission, if you are sending something to moon, then there can be 3 types of mission. I can have an orbiter, ये आप साइड में कहीं पे लिख सकते हो. We can have a lander, and we can have a rover. As the name suggests, orbiter का purpose होगा that it is only going to orbit around another celestial object. It is not going to actually land on the surface. It will orbit around another celestial object because of gravitational force. Okay. So lander है, as the name suggests, now this is going to land. That it is going to often separate from the orbiter or from whatever device it has been launched. It is going to separate from it, and it is going to land on the surface. It has to do this landing with 0 velocity. Otherwise, because as objects fall down towards any celestial object, their speed is going to increase, and we need to reduce that speed very close to 0 the moment they touch the surface, so that they do not get destroyed because of the impact. So Chandrayaan 1 was only an orbiter mission. It was launched by ISRO in 2008. It remained active for about a year only. एक साल के लिए active था. After a year, we lost the contact with this particular mission. But even in 1 year, the amount of information this mission collected proved to be quite useful. For example, we got to know that water vapor is present in lunar atmosphere. So water is present on moon. That's one of the most remarkable discovery made by Chandrayaan 1. And there had been many hypotheses before that, and that hypothesis was further confirmed by Chandrayaan 1. Chandrayaan 1 also confirmed another hypothesis, that moon was at one point of time in a molten state, very similar to Earth. So when Earth was also formed, it was a gaseous giant. It then existed perhaps in a molten state, and finally the top surface solidified. So even moon, we know that moon ka jo formation है, the best accepted theory that how moon was formed, that when Earth was formed about 4.5 billion years ago, about 4 billion or 3.5 billion years ago, there was, or perhaps 4 billion years ago, there was another celestial object which collided with the Earth. And at that point of time, Earth was a gaseous giant. And that led to one of the part of Earth which got separated, and that became moon. It found a stable orbit around Earth. That is the most accepted theory how moon was formed. And very similar to Earth then, even moon was in a molten state. It was not in a solid state. This hypothesis is called ocean magma hypothesis. Magma is a molten material often used for volcanic eruptions. जब भी volcanic eruption होगा, there will be a molten material which will come out, and as it comes on the surface, it then cools down and becomes solidified. So moon was in a molten magma state, and this hypothesis is called magma ocean hypothesis, and that hypothesis was also confirmed by the data collected from Chandrayaan 1. Chandrayaan 1 also found traces of many minerals on the surface of moon. So very successful mission, even though it was there only for 1 year, and only an orbiter mission. We did nothing else. Mars orbiter mission, as again यहाँ पे नाम से ही clear है कि this was only also an orbiter mission. Last year or 3 years ago, we lost the contact with Mars orbiter mission. This was launched in 2015 or 2016. I think 2016 perhaps. And Mission Mangal is popularly called Mission Mangal. And it made lot of records. The first record it made was that ISRO became the first agency to have a successful Martian mission in its very first attempt. So before ISRO, many other agencies had already achieved Martian mission, but ISRO was the only agency, and till date it is the only agency to have a successful Martian mission in its very first attempt. So that in itself was a record. The second record it made was that the entire mission ka jo cost hai, that was very less. In fact, there was a very famous data about it, that if you calculate the kilometer between Earth and Mars, average distance, and you then divide that by total cost, the per kilometer cost was like 5 rupees, जो कि auto के cost से कम है. So that was also a very famous fact here, that per kilometer cost is less than what it cost on an auto, let's say in India. So that was another record, and this was also an orbiter mission. There were a lot of payloads, a lot of scientific instruments, and they collected some data about Mars. They collected pictures of craters on the Mars, and that has also helped us in knowing more about Mars. Mars is a planet which is of great interest for human beings because it falls in what we call Goldilocks zone. Another term which you can write down perhaps somewhere. आप साइड में लिख सकते हो. एक टर्म हम यूज करते हैं एस्ट्रोनॉमी में, स्पेस टेक्नोलॉजी में. दिस टर्म इज कॉल्ड गोल्डीलॉक्स जोन. गोल्डीलॉक्स जोन का जो ओरिजिन, जो गोल्डीलॉक्स वर्ड है, इट इज अ चिल्ड्रन स्टोरी. देयर वाज अ गर्ल नेम्ड गोल्डीलॉक्स हु वेंट टू अ बेयर हाउस and it found a chair which was very strong, or it was very uncomfortable to sit with, another which was very soft. Then it found a chair which was the perfect softness. It found what milk which was very hot, milk which was very cold, but milk which was gunguna milk, and that was perfect milk. So that it's a very famous children's story, that a girl going to a bear house and finding the right chair or the right milk or the right food. So now this term is used in many other cases. In space technology, Goldilocks zone will mean that we are talking about planets which are not very close to their star, or also not very far away from their star. Because if they are very close to star, the temperature will be so high that life will not be possible. And planets which are very far away, their temperature often will be quite less, that life will not be possible. So in both these extreme cases, life will not be possible. So we should think for, or we should then explore those celestial objects or those planets or moons which receive optimum amount of light, and the temperature is also optimum, it is not an extreme level, so that life is possible here. So Earth is of course in Goldilocks zone, goes without saying. Moon is also in Goldilocks zone, but so is Mars. Mars is also in Goldilocks zone. Mars has the possibility of life. Some scientists also think that maybe Mars had some microbial life few billion years ago, but that life did not survive. Right? Mars is a colder planet. It's much cold actually. The surface is quite cold. There are only some places in cave formation where temperature comes about 20-30 degrees Celsius, which is livable condition. But surface is quite cold, by the way. But nonetheless, this term Goldilocks zone we should know. And why Mars? We explore Mars so much. Many space agencies, including SpaceX, for example, Elon Musk has this plan that we want to colonize Mars, that this is another planet which can be colonized by human beings. So anyways, this is why Mars is a planet of interest, and ISRO also has launched a mission called Mars Orbiter mission. It remained active for like 6-7 years. As of now, we have lost the contact with this mission. AstroSat was the first astronomical observatory. Think of this as a telescope. The purpose of astronomical observatory will be to know about astronomical phenomena and other type of astronomical objects, like think of black holes or neutron stars or supernova. We will talk about all of these words in later classes. What is supernova? What is a neutron star? I'm going to explain all of those things, not here. When we will study about Dr. Subramaniam Chandrasekhar, I'm going to explain all of these terms here. But the purpose of AstroSat was to know about cosmic phenomena, events which are happening in universe, as well as distant stars and galaxies. This remains even today active. AstroSat was launched again in 2015 or 16. And even today it is active, and it is sending from time to time. It does give us important information. Chandrayaan 2 was launched in 2019, and Chandrayaan 2 was now much more ambitious than Chandrayaan 1, because Chandrayaan 2 had an orbiter it had a lander, and it had a rover. The orbiter carried the lander and rover. The orbiter still is active. The orbiter is still revolving around moon, and it is still providing important information about moon. But when lander and rover separated from the orbiter, lander and rover will be separated together in one box. Think of this as like one suitcase. When they got separated, it should be very clear that when they get separated, उनका खुद का अपना एक speed है, and as they fall down on the moon, their speed is further going to increase, particularly their vertical drop, that is further going to increase. And we need to ensure that the speed comes to 0 when they are just close to the surface of moon, otherwise they are going to crash. And this is exactly what happened. Chandrayaan 2 ka jo lander and rover tha, that crashed, and all of these scientific instruments which were part of lander and rover, they were destroyed. So we lost the contact with lander and rover, but orbiter still remains. So not a complete failure, but also not a complete success. So Chandrayaan 2 was much more ambitious, but a major part of it, and that was also the most difficult part, that we could not do successfully. Right? So these are some of the past missions we should know about. With that, I can start with, in fact, Chandrayaan 3 only. Let's start with Chandrayaan 3, then we will discuss about Aditya L1 mission. I'm not going to make you write anything about Chandrayaan 3 or not a lot of information, because I did expect a question on this topic last year mains, and there was a question asked by UPSC of 15 marks. So 250 words, 15 marks, you had to write about Chandrayaan 3. But I'm going to tell you that what did we do in Chandrayaan 3 and how did we finally achieve that soft landing on the surface of moon. Like what were the arrangements made by ISRO so that we could soft land on the surface of moon. This is the entire Chandrayaan 3 module. Now, this is what was carried by LVM-3. जो हमारा rocket is सबसे powerful rocket. This is what was carried by LVM-3. But this can be divided into 3 parts. 2 parts are visible. The third part is inside this particular module. तो ये जो module है, this module here is called propulsion module. Chandrayaan 3 did not have any orbiter. ज़रूरत नहीं है. We already have an orbiter of Chandrayaan 2, which still is active. But something needs to be, and ये जो module है, this is the lander which landed on the surface of the moon. This is the lander module. Lander module, इसके आप दिख भी जाएंगे, इसके जो legs हैं, you can see all of those legs. And inside that lander, there is a rover module. It's not visible in this picture, but inside this lander, there is a rover module. Rover का काम जो होगा, as the name suggests, it is going to rove around. It is going to roam around on the surface wherever it has landed. So while lander will remain at one place, rover is going to roam around and will collect sample and will conduct experiments then and there, and will send data about those experiments on the ground stations. So how Chandrayaan 3 occurred? The first part of the launch, I told you in the last class itself, that we used LVM-3. LVM-3 launched this Chandrayaan 3 module, this entire part, into an orbit, which is an earthbound orbit. We do not have a very powerful rocket so that we can attain escape velocity in very one go. We do not have that. So what we do here in such cases is that we launch a satellite, such type of lunar missions or even Martian missions. We will launch into an earthbound orbit and we will keep giving them a boost at the perigee or apogee so that we keep raising their orbit. But ये जो है, इसके लिए हमको फ्यूल चाहिए. वो फ्यूल किससे आएगा? Propulsion module से. So that was the purpose of propulsion module. Propulsion module had its own liquid fuel, that MMH plus MON, which I discussed in the last class, that monomethyl hydrazine. So it has its own fuel, it has its own motor, and with the help of that fuel and motor, we keep raising the orbit. When it reached at some height, then we gave it a boost so that now it can cross Earth's gravitational barrier and it can start its motion towards Moon. Here also, the first orbit we achieved was this orbit, but then we kept reducing the speed. All of that was pre-planned so that we can keep decreasing the orbit. And finally, we achieved an orbit which looked something like this, very close to the surface of Moon, about 100 kilometers. So initially, this is a highly elliptical orbit, few thousand kilometers away from Moon. But the final orbit, before lander could separate, we were close to, in fact, less than 100 kilometers around Moon. So propulsion module now is revolving around Moon in almost 100 kilometer circular orbit. And then the lander got separated. Lander had lot of arrangements now that how to ensure soft landing. So what lander had? Lander was equipped with many type of sensors. Sensors क्या होते हैं पहले तो? I'm using a word here. Sensors. Sensors का purpose होता है that they collect some data. Even if they are collecting some data and telling us, even then they are sensor. But if they collect some data and based on that data they can execute a decision, then they will be much more better sensors. So those sensors are equipped with their own computational system. They have their own cyber component. A computer hai, that computer is collecting some data and based on that data it is executing some instruction. Just think of your human brain as a computer. Human brain, by the way, is a computer. It is one of the most powerful computers we know of. And this brain is connected with so many different type of sensors. Our eyes are sensors, our ears are sensor, our skin is sensor. That eyes as a sensor, it is gathering light, and based on that, brain processes that data and it allows us to look to our surrounding. Ear as a sensor allows us to listen. Skin as a sensor tells us that if, let's say, for example, something hot has fallen on the skin, you immediately know about it. So the same thing, of course, much less sophisticated, but we can also do that in our day-to-day life. Jaise you go to metro, Delhi metro, jo escalator hai ruka hua hai, but the moment you come close to the escalator, it starts moving. So why does it start moving when you are close to the escalator? Maybe just below the escalator, there is a pressure sensor. The purpose of that pressure sensor is that the moment you put your foot here, it knows that now there is a heavy mass here. And based on that, there is a computer which gives an instruction that the moment this pressure increases beyond a point, the escalator will start moving. And think about that sensor, how much role it plays. अगर escalator हमेशा चल रहा हो, तो कितना सारा energy consumption होगा जिसका use नहीं है. So just by applying a small sensor, we are able to conserve energy. Or think of so many taps, उनका कोई button नहीं है, just you have to put your hand below the tap and water will start coming out. There is a thermal sensor clearly, which is measuring infrared sensor of your hand, and based on that, a decision is being taken that water will come out. So Chandrayaan 3 का जो lander है, that was equipped with many type of sensors, and it was equipped with a very powerful computer system, which was part of the lander module. One of the sensor, for example, was velocimeter. In fact, there were two velocimeter. A thermometer as a sensor measures what? What does thermometer measure? Temperature. So I'm using a term velocimeter. What will that measure? It is going to measure velocity. So it had two sensors. Both of them were velocimeter. One velocimeter was measuring the horizontal velocity, because imagine how this must have been happening. This is moon. This is the propulsion module, and the lander had separated. But now this lander has a vertical velocity as it falls down towards moon, and इसका खुद का अपना एक horizontal velocity भी है. So there was a velocimeter which was calculating its horizontal velocity, and by the way, both of that has to come to zero, because मान लो vertically जब आप land कर रहे हो और ये speed करीब करीब zero है, but आपका horizontal velocity फिर भी है, so you are going to topple down, आप गिर जाओगे. और अगर vertically बहुत तेजी से गिरोगे, आप crash कर जाओगे. So both of that speed has to be very close to zero. So there were two sensors. One sensor was calculating its horizontal velocity all the time. Another sensor was calculating the vertical velocity all the time. And based on that data, there was a computer system which was pre-programmed that the moment it reaches to a particular horizontal velocity or particular velocity, then we need to apply some sort of brake, some sort of thrust in the opposite direction so that we get to reduce the speed. आप में कितने लोगों ने लाइव लैंडिंग देखा था यूट्यूब पे? बहुत सारे लोगों ने देखा था. अगर नहीं देखा है जिन्होंने, आई हाईली रिकमेंड कि वो भी इसरो के यूट्यूब चैनल पे अवेलेबल है. Just go and watch the last 10 minutes of that video. That all of this was live telecasted. That live telecast is available on YouTube channel of ISRO. And you'll remember that before it could touch down on the surface, many times before that, people clapped. So why were people clapping? People were clapping because whatever was pre-programmed, we were not giving any instruction from the ground. Should be very clear. Nothing was being done from the ground. From ground, we were only observing that what is happening. And every decision which this lander has to take, it was pre-programmed as part of its computer system. So based on some data of horizontal velocity or vertical velocity, when it successfully executed an instruction, then it means one part is successful, and people were clapping for that. So 2 sensors, 2 velocimeter, 1 altimeter. Altimeter, what will that measure? Altitude, कि moon से कितने ऊपर है. And based on the altitude, based on the velocity, it had to apply its brakes. There was also a phase which was called hold phase, that before it could go further, as it was falling down, it was falling like an object which is like this. And before it can go on the surface, it has to reorient. So it has to rotate, and it has to perfectly align itself so that when it falls down, all of the 4 legs are falling vertically. So that was also a phase where we reoriented its direction. So it is like this, a box like this, but we reoriented so that it becomes vertical. That was also a phase. Then just before touching the ground, there was an upward thrust so that its speed becomes almost 0. And last but not the least, this lander module was equipped with a camera. That camera was recording the site, that live site. And it also had a type of AI technology, which I'm going to discuss, and an element of artificial intelligence, which is called computer vision. हम discuss करेंगे AI में इसको. Computer vision का purpose क्या होगा? That it will take visual input and it will execute some sort of instruction, some sort of decision making. So there was a live camera which was recording the landing site, and it was figuring out that if this landing site is safe or not. जैसे मान लो there is a big rock on one of the legs. If you land there, not all 4 legs are on the same flat ground, you are going to topple. The moment you topple, आपका पूरा rover fail हो गया, rover आपका काम नहीं करेगा और lander भी काम नहीं करेगा. Does not make sense. So there was the third arrangement was that it also had a live camera which was doing a recording of the landing site, and based on that, the computer had to take a decision that is this landing site safe or not. And then there was a fail-safe mechanism. That fail-safe mechanism was that our ideal goal is that this speed, both horizontal and vertical speed, should be 0. But even if it is going to fall with, let's say, 3 meters per second, it's going to safely land. So lander के जो legs थे, they had all of this arrangement that we are going to safely land, even if that speed is not 0. But the speed was exactly 0. If you have watched that live video, you'll realize, or you'll remember that just before landing, both of this speed was exactly 0. So all of that arrangement together allowed that Chandrayaan 3 successfully landed on the surface. And the moment when ISRO did that, ISRO became the 4th agency to successfully do it. So US was the first country to do that Apollo mission. Then you had Russia, which successfully did that. China did that few years ago. And India became the 4th agency to do that. As of now, even Japan has done it. So Japan, a few months, in fact, 3-4 months ago, one of the mission of Japan, it is called SLIM mission, SLIM. So SLIM mission of Japan had successfully landed on the moon. So that is about one part of Chandrayaan 3, that how did we successfully execute that soft landing. The second part of that mission is that what we aimed to do from Chandrayaan 3 mission, like what are the scientific objectives of Chandrayaan 3 mission. This was also asked by UPSC, that what are the scientific objectives of Chandrayaan 3 mission. So scientific objectives को समझने के लिए I'm going to give you हैंडआउट जो स्लाइड्स जो मैं दिखा रहा हूँ अपलोड हो गए आपके पोर्टल पे? मैंने फर्स्ट क्लास के बाद भी मेल कर दिया था. Anyone will confirm that has it been uploaded? Okay, so it has been uploaded. So on the same slide, you'll find this, that all the scientific payloads which are part of lander module. So lander module एक तरीके से समझ लो कि एक सूटकेस है, बट सूटकेस में अलग अलग साइंटिफिक इंस्ट्रूमेंट्स रखे हुए हैं. जो सबसे पहला साइंटिफिक इंस्ट्रूमेंट है, we call this Rambha. The full form is Radio Anatomy of Moon Bound Hypersensitive Ionosphere and Atmosphere. तो Rambha का जो पर्पस है, the purpose of Rambha payload was to know that if there are charged particles near the Earth's surface. जो ये लैंडर का पार्ट है, it is not going to roam around. Wherever we have landed, we are going to see that if there are charged particles, जैसे where I am standing, if I have to know that are there charged particles here, and how do we know that? There is a very famous probe, there is a very famous scientific probe which is called Langmuir probe, named after the scientist who actually developed it. So there is a probe here called Langmuir probe. Langmuir probe का पर्पस ये है that it is going to figure out that if there are charged particles in the vicinity. So why this scientific payload? Because our goal here is to understand if communication from moon will be easier. If there are a lot of charged particles, then maybe there is a chance that our communication systems will be affected. So this already has given us important data that there are charged particles, but they are very thin. जो charged particle density है moon का, वो बहुत ही कम है. So our communication systems will not that adversely affected on moon surface. That is the first thing. The second scientific payload was called CHAST, Surface Thermophysical Experiment. As the name suggests, it is going to measure the temperature of the moon surface. But ये इसका जो गोल था, that temperature हम surface पे measure करेंगे, and वहीं पे जहाँ पे land हुआ था, lander is going to dig the surface up to few centimeter, and we'll see that what is the internal temperature, like few centimeters below, what is the temperature. And there was a very surprising finding that surface temperature was about 70 degrees Celsius, which was not expected. So we already have some data here that the surface temperature was about 70 degrees Celsius, and just few centimeters below the surface, the temperature suddenly dropped and it came very close to, in fact, 0 degrees Celsius. So that was also a finding of CHAST. The third was instrument for lunar seismic activity. जैसे अर्थ पे अर्थक्वेक्स होते हैं, मून पे भी मूनक्वेक्स होते हैं, बट जो मूनक्वेक्स हैं वो इतने पावरफुल नहीं होते. So to know about moonquakes, their intensity, their impact, the third scientific payload observed that, and yes, it has found evidences of moonquake, but it does not know why that moonquake is there. जैसे अर्थ के केस में why earthquake happens, we know. We have a very good understanding that why does earthquake happen. But moonquake क्यों होगा? What is the exact mechanism of moonquake? We need more data to know about that. And another payload was laser reflective retro reflector array. इसका पर्पस ये है that जो मून है वो अर्थ से थोड़ा दूर जा रहा है. हर साल करीब करीब 1-2 सेंटीमीटर जो मून है वो अर्थ से दूर जा रहा है. तो 1-2 सेंटीमीटर जो दूर जा रहा है, it does not affect us in 1 year or in 100 year or in even 1000 year, but in 1 million year that effect will be felt. जैसे when moon will, in 1 million year, moon will be much more far away, and because of that the size of moon is going to decrease as we see from Earth's surface, if we do survive for 1 million years. Human beings, if we do survive for 1 million years. So moon's position is changing with respect to Earth, and the goal of this payload is to know how that position is changing. And the rover payload, rover had 2 payloads very similar to each other. There are type of devices which we call them spectrometer. Spectrometer is used to do spectroscopic analysis. Now I will be talking about spectroscopy in great detail in later classes, but I just right now want to highlight one line that spectroscopy का main goal है कि हमारे पास sample दे रखा है. जैसे मान लो पानी का sample है, मान लेते हैं कि इस पानी में कुछ impurity है, there is some impurity in this water, let's assume that, and a spectrometer will tell you exactly what type of impurities there are. So I have been given a molecular sample, and I can analyze that molecular sample and I can figure out that what it is made of and what are the composition of various things. That is the purpose of spectrometer. So rover module had two type of spectrometer, and both of their purpose was to collect the soil sample where the lander landed and the rover roamed around, and do an in situ experiment. In situ ka matlab then and there experiment, and then provide information back to Earth. So this was about rover module, two scientific payloads there also. And the propulsion module, now of course the propulsion module ka jo purpose hai, that purpose is to carry the lander and rover, but ISRO also wanted to do two things here. Propulsion module collected some information about Earth from very far away, that how will Earth look from so far away. That is the first thing. And there was a payload called Shape for that. But the second thing which ISRO wanted to do, and it has successfully done that can we bring that propulsion module back to Earth? So back to Earth's orbit, not on the surface, but right now we sent propulsion module from Earth to Moon. It revolved around Moon because of Moon's gravity, but can we give it a boost in a way that it now starts its motion towards Earth, and can we bring it back to an Earth-bound orbit? And as of now, ISRO has successfully done that. So as we speak, propulsion module is not revolving around Moon, it is revolving around Earth. It has lost all of its fuel. It does not have any amount of fuel now. This was information given by Minister of Science and Technology just last month in Parliament, last month in Parliament, that propulsion module has exhausted all of its fuel, but it is revolving around Earth now. So it carried to the Moon, and it came back, and it is now in an Earth-bound orbit. Now this is a great news, because now ISRO is planning Chandrayaan 4, and maybe we are planning that by 2040 we will send human beings on the surface of Moon, and this success, that we can send something to Moon and we can bring it back, will play a very important role in that successful manned mission on the lunar surface. So that is why propulsion module jo hai, it is very important. So three different type of modules. Think of this as like three different type of suitcase. Propulsion module carrying the two suitcase, but inside a larger suitcase which is lander, there is another smaller suitcase which is rover. And within that suitcase you have many clothes. Clothes ka matlab yahan pe scientific instruments hai. There are many scientific instruments. I'm calling them payloads. And those scientific instruments are collecting various type of data. So Chandrayaan 3 has been one of the greatest success of ISRO, only the fourth agency to do that. And that also now allows India to participate whenever there is, let's say, a global space treaty going on. That global space treaties have to be negotiated. Then India will be now an active participant there. So India's opinion will matter now. So that also is very important, that in global space negotiations, a country gets to enhance its saying in such type of negotiation. There are other benefits also. I will talk about that in Gaganyaan. So this much information about Chandrayaan 3, I think you should know. I do not expect a question anymore on this topic, perhaps except in prelims examination this year. But I do not expect a question in mains examination. But nonetheless, the awareness about this topic and how all of that happened can be very useful. As a candidate, you should know about it, right? So the detailed information about all of the sensors, all of the payloads, and what Chandrayaan 3 aimed to do, I'm going to give you a handout for that, right? So I'm not going to make you write anything about Chandrayaan 3. If you have any question, by the way, sorry, one more thing I should tell you about Chandrayaan 3, that where it landed, that is also very significant. So Chandrayaan 3 landed near South Pole, not exactly on South Pole, जैसे जिस तरीके से Earth पे North Pole and South Pole है, वैसे ही Moon पे भी North Pole and South Pole है, and very similar to Earth's North Pole and South Pole. South Pole of Earth is much larger. Antarctica is much larger than Arctic. So lunar South Pole is also much larger than lunar North Pole. Now Earth का जो orientation है इस तरीके से है, that the way Earth is oriented, that half of the year on poles you have day and half of the year on poles you have night. But Moon's orientation with respect to Sun is in a way that South Pole always remains in darkness. So South Pole never receives sunlight. And why this is important? There are 2-3 things which are as of now hypothesis about South Pole. The first is that South Pole का जो characteristic है, the characteristic of South Pole has not changed in last few million or even billion years because it does not receive sunlight. Sunlight plays a very important role in transformation about a particular surface. Just if I have to know about early solar system, what was early solar system, then Earth is not the best place to know that, because Earth is a very dynamic planet. There is life on Earth, and every few thousand years, Earth's surface keeps on changing because of all of the erosional agents, depositional agents, because of all of the life which flourishes on Earth. So if I actually want to know about Earth or solar system, early solar system, what it was 4 billion years ago, then we should go to asteroids, we should go to some other planets. So moon ka jo south pole hai, that is also a place, because the underlying assumption here is that moon's south pole has not changed a lot in last few billion years. So exploring lunar south pole will allow us to understand more about solar system in general. That is the first thing. Second thing, there is another hypothesis that jo lunar south pole hai, that has huge amount of ice here, water ice. And that ice can be very helpful, because if we make a colony on moon in future, then this water will play a very important role for life, but also for fuel, because we can remove hydrogen from that water, or we can collect hydrogen from that water. And hydrogen is a great fuel, by the way. I told you in the last class also that hydrogen is a great fuel. So now we can make a station on moon, and from moon we can now send probes to some other planets, or we can come back to Earth also. But for that, we do not have to carry fuel. We can extract that fuel from the moon itself. So that is why exploring South Pole is very important. So we did not land exactly at 90 degree. We landed at about 70 degree latitude. So close to South Pole. Not exactly at the South Pole, but very close to South Pole. And ISRO became the first agency to be so close to South Pole, because till now all of the landing, they have been around the equator of moon. So make a equator on moon, and all of the landings have been either 20 degree north or 20 degrees south. But this was the first mission which went to 70 degrees south. That is also in itself an achievement. So exploring lunar South Pole. The last thing, nothing to do with Chandrayaan 3 mission per se, but you will come across a term called dark side of the moon. Suna apne ye term? Anyone will tell me what is that dark side of the moon? But that is not correct actually. So you will think that dark side of the moon is south pole of moon, which does not receive sunlight. But not at all. Dark side of the moon, when we use this term, it means the part of moon which we do not see. Now I will answer your question about tidal force. You come across a term, geography may will be taught about tide. If your geography, I don't think your geography classes have started, but you will be taught about tides. Or I think you have some idea about tides, that high tide, rising of ocean water and falling down, and low tide, not that much high, but still there is a tide and falling down. You know about this. And you also know that it has something to do with moon's gravitational pull, and also perhaps sun plays some role. So you know 2-3 things about tide here. That you have this high tide, low tide, because of moon's gravitational pull, ocean water goes up and comes down, and we call that tide. I will come to, that is not the exact meaning of tidal force. And what exactly is tide? We should revisit that concept. But before that, coming back to my point, that moon ka jo ek part hai, the part of moon which we see during night, we always see only that part. We never see the other part of the moon. So that invisible part of the moon, which we never see, that part is called dark side of the moon. So dark side, in a way that it is dark side for us, we do not get to see it. But that does not mean that that part, half of the moon, the other part, does not receive sunlight. It receives sunlight. It does receive sunlight. But we do not get to see it, and we call it dark side of the moon. However, South Pole literally does not receive sunlight. So South Pole hai, wahan pe koi sunlight nahi hai. For millions of years, for billions of years, there has not been any sunlight. So why does that happen? Uska ek bahut simple karan hai. Earth rotates on its axis in 24 hours and revolves around sun in 365 days. The moon revolves around Earth, we know that. That moon is revolving around Earth in an orbit of about 384,000 kilometers. How much time do you think moon takes to complete its rotation on its axis? We know how much time it takes to revolve. How much time it takes to revolve? 28 days, about 28 days. If I have to approximate, then moon completes one revolution around Earth in 28 days. But how much time it takes to rotate on its axis? Exactly 28 days. So the time it takes moon to rotate, the same time it takes moon to revolve. And you'll think that this is a coincidence. It is not a coincidence. This has something to do with called tidal locking. There is a phenomena called tidal locking, and moon is tidally locked to Earth in this particular case. That its rotation and revolution matches exactly with the same speed, and because of that, as it rotates and as it revolves, we only and only see one part of the moon. We do not see the other part of the moon. But this did not happen when moon was formed. This happened in the course of time. And that has now something to do with this concept of tidal force. So let me revisit the concept of tidal force. Think of that on Earth, there is a rod falling down. This rod is of length L. And it is falling down from some height h here. So what we do when we do our normal mathematical calculation, we often take the midpoint of this rod, and based on that we calculate that what is the height of this rod and how much it is going to accelerate. So we assume that this part of the rod and this part of the rod is going to experience the same gravitational force. We assume this. And as long as this rod is not very large, मान लो I have a rod of let's say 1 meter or 100 meter, my assumption will not be wrong. But now imagine a rod which is let's say 500 kilometer thickness, and it's not falling like this, it's falling vertically downward. Imagine a rod falling on Earth vertically downward, but now this rod is not 1 meter, this rod is 1000 kilometer. And a 1000 kilometer rod is going to experience different gravitational force. The part of the rod which is closer to Earth will experience much more gravitational pull. The part of the rod which is going to be farther away from the rod will experience much less gravitational pull. So whenever same object, one part is being stretched, the other part is not being stretched so much, it will cause deformation, won't it? I have an object, I'm trying to pull one part of it. And if my force is enough, and if this object is not very strong, I'm going to deform this object. This is exactly what is going to happen. So gravity does the same thing. So when I use the word tidal force, the first thing you should know is the tidal force is not because of moon's gravity. Tidal force, I can use it for any object. Two objects gravitationally attracted to each other, but one part of the object, which is closer to the other object, will experience much more gravitational force. The other part of the object, which is farther away from the object, will experience less gravitational force. That difference is called tidal force. So tidal force is a term which we do not have to define it only for Earth and Moon. We can define it for any two objects which already are gravitationally attracting each other. Jaise, this is Earth, this is Moon. Now I assume that the distance between center of Moon and center of Earth, and I assume that the average gravitational force is because of this distance. But clearly this part of the Moon is going to experience much more gravitational force, and this part of the Moon is going to experience less gravitational force. This difference is called tidal force, and one of the effect of tidal force is that it starts causing a torque, and that torque starts operating in a way that if Moon was formed and if its rotational velocity was very high, let's say that even Moon was rapidly spinning on its axis in let's say 1 hour, it was completing one rotation. But because of that tidal difference, there will be a torque, and this torque is going to slow down rotation of Moon. And this slowing down will keep on happening till the point of time when the rotation and revolution exactly matches each other. Now why does that happen? Again, we have to go to mathematics for that, which we do not have to do in this class. But the moment the angular velocity of rotation and the angular velocity of revolution, when that matches each other, then this torque will cease to exist and no longer there will be any fasting or slowing down of this rotation or revolution. So revolution तो हमेशा सेम होगा, इस बात पे डिपेंड करेगा कि आप अर्थ से कितना दूर हो, बट रिवोल्यूशन का जो एंगुलर वेलोसिटी है, द एंगुलर वेलोसिटी ऑफ रिवोल्यूशन एंड द एंगुलर वेलोसिटी ऑफ रोटेशन, इट हैज टू मैच ईच अदर, and then this is called tidal locking. So Earth has tidally locked Moon with respect to itself. So Moon is tidally locked, and because of that, as it rotates and as it revolves, we only see one part of the Moon. The other side of the Moon is called dark side of the Moon. Then you ask this question, that can Moon tidally lock Earth? If Earth has this impact on Moon, then even Moon has the same impact on Earth. So yes, the answer is yes. The problem is that Moon is a very smaller object compared to Earth. And because of that, जो Moon का जो tidal difference है, that will not cause lot of change to Earth's rotation. Or the change, whatever is happening in 1 day or 1 year, is negligible. Maybe in few billion years, Earth will be tidally locked to Moon. But it will take another few billion years before it can happen. It is not going to happen anytime soon. But if I had two common mass objects, just say, go to Pluto. Now, Pluto as of now is not a planet. One of the reason it is not a planet is because Pluto has few moons. One of the moon of Pluto is called Charon. And Charon का जो size है, वो Pluto से बहुत ज़्यादा छोटा नहीं है. वो Pluto से कुछ 1/3 size का है. And Charon and Pluto, they both are tidally locked to each other. So now what is happening in case of Charon and Pluto is that Charon looks the same side of Pluto and Pluto looks the same side of Charon. So both of them are tidally locked to each other. अगर same चीज Earth and Moon के केस में हो जाए, then again same thing is going to happen, that Moon is going to only see half of the Earth. But as of now, Earth is not tidally locked to Moon, but Moon is tidally locked to Earth. But still there is one impact which we cannot ignore, and that impact is that Earth has ocean, Earth has water around it. You have 70% of Earth, जो surface है, that is water. But the part of Earth is going to feel a much more attraction, and because of that, it is going to create a bulge. It is going to create a bulge in the direction of Moon. But the other part, which is experiencing less force, that will also have a bulge, but in the opposite direction. So we have now two bulges on the Earth because of ocean. So ocean water has a bulge, the side which is facing the Earth, there is a bulge here, and the other side has a bulge in the opposite direction. And Earth is rotating inside this bulge. So what we think of as high tide or low tide, this is our perspective. If somebody goes outside Earth and will look at the entire Earth simultaneously, that somebody will find that you always have this two bulge and you are rotating inside this bulge. So whenever you are coming here, you are experiencing high tide. And whenever you are coming here, you are experiencing low tide. So there is nothing high tide and low tide per se, in fact. You have these bulges and you are rotating below or inside that bulge. And whenever you are at this bulge, you have this high tide. And whenever you are at this bulge, you are experiencing a low tide. So tidal force का मतलब simple सा है, that an object which is experiencing differing gravitational force as it is at different distance from another heavier object, that difference is called tidal force. अगर मून बहुत पास में होता अर्थ के, then मून का जो अर्थ का जो tidal force का जो impact होता, वो इतना ज़्यादा strong होता that it would have shredded apart moon. It would have divided moon into few parts, because the half of the moon would have experienced much more pull. The other part of the moon would not have experienced that much force, and moon would have been divided apart. But moon is at the right distance, that Earth does not do that. So this is also thing. There is a safe zone of distance. If you are not within that safe zone of distance, then you will be tidally ripped apart because of another heavier object, right? You can now ask few questions, that why is Earth not tidally locked to Sun? If Earth and Moon can tidally, if Earth can tidally lock Moon, so why had Sun not tidally locked Earth here? The answer is simple. Earth is very far away. Earth is 150 million square kilometer distance, and Earth has a radius of 6,400 kilometer. So compared to that 150 million kilometer, now imagine a situation that this is Sun, this is Earth, this distance is 150 million kilometer, and Earth का जो radius है वो क्या है? 6400 किलोमीटर है. So 150 million में I add 6400 kilometer and 150 million में I subtract 6400 kilometer. This two value will be same as 150 million kilometer, like not literally same, but the difference will be negligible. So ये 150 million के सामने 6400 इतना छोटा value है that we can easily neglect that difference. So even sun causes this tidal effect on earth, but that tidal difference is so negligible that earth is not tidally locked to sun. By the way, if it was the case, there would not have been life on earth, because half of the earth would have always received sunlight, very hot. Half of the earth would have never received sunlight, very cold. Life would not have been possible anywhere on this planet. You ask a question, what about Mercury? Is Mercury tidally locked to sun? Because Mercury is now closer. Now Mercury is also not tidally locked. But that is because of Venus. That yes, you have sun, but you also have Venus. And Venus का जो gravitational pull है in the opposite direction, उसका tidal effect दूसरे direction में है, जो sun का tidal effect दूसरे direction में है. So even Mercury is not tidally locked. But many other objects are tidally locked. There are moons of Jupiter which are tidally locked to Jupiter. You have moon of Pluto, which is both of them are tidally locked to each other. So this phenomena is called tidal locking. And this phenomena was actually utilized in case of Chandrayaan-3 landing. Because moon is tidally locked, moon is going to rotate in 28 days. Earth rotates in 24 hours. So you have about 12-hour day, 12-hour night. Moon is going to rotate in 28 days. So there will be 14 day where one part of the moon will receive sunlight, and 14 day when the other part of the moon will receive sunlight and the first part will receive night. So we planned our landing in a way that when Chandrayaan-3 landed on 70-degree latitude, it started the lunar day. And then it remained active for 14 days. And then it of course went through night. And 14 दिन night का मतलब है जहाँ पे temperature मान लो अभी 50-60 degree Celsius है, the same temperature will go into -150 degree Celsius. ISRO had hoped that when the second lunar day occurs, maybe we will reawaken our lander and rover. ISRO had hoped for it. Although we knew that this is a very slim hope, it is not going to happen, and it did not happen. So Chandrayaan-3 का जो lander है, it only worked for 14 days. 14 day is one lunar day. That for 14 days it received sunlight. And remember, Chandrayaan-3 का जो lander है, it needs power. And that power it received from sunlight. The solar panels of Chandrayaan-3 हैं, they were providing the necessary energy so that it can do all of the experiment and it can send that data back to Earth. But once lunar day occurred, we were not able to re-awake it because it suffered lot of low temperature, lot of coldness, and we could not re-awake it. So as of now, it is just going to stay there for maybe hundreds and thousands of years. We are calling that point at Shiv Shakti point, पढ़ा होगा आपने newspaper में. So it is just going to stay there. So one of the great success of ISRO, one of the greatest in fact, and there was a question asked by UPSC also from this topic in examination. Any questions if you have here till now, you can ask questions. Yeah. The purpose was that can we do that? The question is asking is that there was a news that we fired up the Vikram lander. We call this lander Vikram after Vikram Sarabhai. The purpose here was that जो हमारा Vikram lander है, we fired it up and we hopped it. That we gave it a thrust so that we can lift it up and we can land it again. So the purpose was simply, can we do that? And yes, we successfully did that. That can we execute an instruction from ground where we give a thrust to the lander, where it hops up and then it again lands safely. So the goal here was that are we able to do that? Right? Theoretically, we know that we should be able to do that. But remember, science is not about theory. Science is more about practice. So the goal here was that can we do that in practice? And we did that successfully. No scientific. So in a way, it is a scientific objective. That in a way, it is a scientific objective that can we give it a thrust from Earth? We gave an instruction from Earth. And can we land it safely again? Goes up to height and we safely land it. It will be useful in future missions. Right? That knowledge will be useful in future missions. Any other question if you have? I have a question for you then. Write down a question. Discuss the contributions of ISRO. Discuss the contributions of ISRO in space science and technology. Space science and technology. How does space technology How does space technology How does space technology contribute to socio-economic development of the country? Socio-economic development of the country. How does space technology contribute to socio-economic development of the country? This was a question asked by UPSC, 15 mark to 50 words. I will give you exactly 9 minutes to write down this answer right now, because this is the time you get to write answer in examination. If you have 20 questions, there are 10 questions of 10 marks, 10 questions of 15 marks. If you want to attempt all of them, then you should give 6 minutes to 10 mark question and 9 minutes to 20 mark question. Of course, it's not going to happen. In some questions you have more information, you will exceed a little bit. In some questions you have less information, you will not write that much. So I'll give you 9 minutes. My hope here is that you do not have to write the complete answer, but you have to tell me a detailed approach, and you have to tell me what are the bullet points you are going to highlight in your answer. So you do not have to write that 250 word right here, but you do have to think about a proper detailed approach and all the bullet points you are going to write in the first part and second part. I will give you 9 minutes to do that. Meanwhile, I have some online queries. Let me tackle that. But you think about, and online students also do the same thing. When you are done, you can share your answer with rest of the class. Why we not talk about space observatory satellites? Do you mean space stations? I am going to talk about space station in today's class. Don't worry. There is a question that Elon Musk wants to nuke the poles of Mars so that it would terraform. Will that work? We do not know that. Yeah, I always find that if you can terraform Mars so that it becomes habitable, we can take care of planet Earth only, that it remains habitable. That is easier rather than doing something on Mars. Does propulsion module orbits like orbiter around moon, or it falls on Earth? So as of now, propulsion module is revolving around Earth. Has not fallen on the ground, is revolving around Earth. The orbiter in Chandrayaan 3, why not directly reach in the radar of 100 km? Why it's taken time slowly? We wanted to control everything. So Chandrayaan 2 का जो failure है, that also meant that we have to be very careful in Chandrayaan 3. So we wanted to control each and everything, and because of that, we did that into successive steps. Why can't we see the dark side of the moon? Because moon rotates and revolves exactly in the same time. Please repeat tidal force. Tidal force is that difference in gravitational pull because of an heavier object towards a lighter object. तो जहाँ पे भी extended objects होंगे, one part of the object will experience a more pull, another part of the object will experience less pull. That is called tidal force. Chandrayaan 3 success means India joined elite space club. Does such thing exist? Like, not officially, but unofficially, yes, there is an elite space club, which includes US, Europe, Japan, Canada, all the developed nations, or even China for that matter, Russia for that matter. So not officially, but yes, unofficially, we can say that India is part of an elite space club. I can repeat why Earth is not tidally locked. Because Moon is a very smaller object and Moon का जो tidal impact है on Earth पे वो बहुत कम है. ऐसा नहीं है कि नहीं है तभी तो tides होते हैं. But that impact is so less that it will take lot of time before Earth can tidally lock to Moon. If Moon would have been a very heavy object compared to what it is right now, then yes, it would have tidally locked Earth also. Raise your hand. Yes, go ahead. Yeah, go ahead. Okay, so what I will recommend next time when I give this assignment, that do not try to complete the answer, because right now you have done that and it's not enough. You need to write more points. So what I would recommend, that focus on the bullet. आप घर पे completely time देके आराम से 15 मिनट में लिखना. That all the points you want to elaborate. Initial days में जब आप answer writing करोगे, do not worry about that how much time it is taking to complete an answer. Focus on the quality part. बट फोकस ऑन द वर्ड लिमिट पार्ट, वो जरूरी है, वो आपको शुरू से उस पर काम करना पड़ेगा. फोकस ऑन द वर्ड लिमिट पार्ट, दैट यू आर कंप्लीटिंग एन आंसर इन 250 और 150 वर्ड, no matter how much time it takes. Do not focus on the time part in the initial days of preparation. As your preparation progresses, then once you know that okay, you are writing good answers, you can now focus on quantitative part, that I want to write more and more answer. So your answer, you wrote very few lines about the first part, you gave 2-3 examples in the second part, and then you concluded. So in class, whenever I give this assignment next time, and I will do that in many topics, we will write answer in the class itself. So try to focus upon that what will be the major bullet points and examples. Elaboration, do that at home, but focus upon only the bullet point and what will be the structure of my answer. Okay, anyone else would like to add, contribute? Yes, go ahead. Okay, yeah. You have handled second part really well. So second part जो है, that's a very good answer. Anyone else would want to contribute, that what can we write in the first part and second part? One of the challenge in this answer writing will be that you have a lot of points to write, but you have to complete all of the answer in 125 and 125. Remember, there are two parts of the question, and in both the parts are almost equally important. So you have to write 120 to 130 words in the first part and 120 to 130 words in the second part. How to write all of that, all of the information we have gathered till now, into limited words? That will be a challenge. फर्स्ट पार्ट को कौन हैंड फर्स्ट पार्ट को कैसे हम लिखेंगे लिमिटेड वर्ड्स में? गो अहेड. जस्ट अ सेकेंड. ऑनलाइन स्टूडेंट्स, सो आप जब आंसर लिखोगे तो आप एक पैराग्राफ में तो एक ही सब कुछ नहीं लिखोगे. you'll always make a structure. So even also when you are posting on response portal, tell me about your structure rather than writing everything in one paragraph. Tell me more about this structure you are going to adopt. Yes, go ahead. Okay. Yeah. I think this is again a very valid approach to write down the answer. How you are going to write? Yes, go ahead. सेकेंड पार्ट में हम पहले पार्ट में अगर हम डिटेल में सैटेलाइट्स के बारे में बता के और एप्लीकेशंस लिखने लगे हर सैटेलाइट के बारे में, देन इट विल टेक लॉट ऑफ वर्ड्स and that's not desirable. But nonetheless, first part mein we definitely so I think first part can be dealt in an intelligent manner, that without going into details of all the types of satellites or all the types of space mission, you mention about them, and the most important thing which you can think about a particular type of satellite or a particular space mission, mention that. That's it, nothing else. In the first part, I think you can divide your answer into 3 parts. The first part in itself, yes, go ahead. Okay. You wrote about Nisar mission in the introduction itself. Don't do that. It will be it will seem like a very sudden introduction. Introduction should be very simple. Like it shouldn't be that you are directly jumping in the answer part. Like Nisar mission will be one of the bullet points in the main body of the answer. Uh, Write down. You can write a general introduction, or if you wanted to start with some current affairs bit, then you could have perhaps started with Chandrayaan 3. That will perhaps be a better option rather than Nisar mission, which is a very niche mission. Nisar mission जो बहुत ही niche mission है, but everybody knows about Chandrayaan 3 mission, right? So if you wanted to start with current affairs bit, you could have done with Chandrayaan 3. That would have been a better introduction. But what are the bullet points you have written in main body? Okay. Also mention Chandrayaan 2. Don't forget Chandrayaan 2. The second part hai, I will just make some modifications. Most of your points are valid. I will make some modifications. So let me, I have to go to the next topic. So let me tell you, I think, according to me, what can be an approach to answer this question. The first part, write down a general introduction about ISRO. You can start about its inception. You can write about Vikram Sarabhai, whatever you do, but don't write more than 20 to 30 words in the introduction. Whatever your introduction is, I often feel like that students worry a lot about introduction. You have to worry a lot about introduction in essay. In mains answer writing, do not worry that much. Whatever comes to mind, logically write it down. There is a keyword in the question, define that keyword. You had to write about ISRO's contribution, talk about ISRO's history itself. Whatever you want to do that, but do not spend a lot of time in the introduction itself. You have very limited time and you have to write a lot into 50 words. So introduction cannot take a lot of word. Main body, I think we can divide that into 3 major bullet points, and those 3 major bullet points will contain sub bullet points. The first major bullet point can be, you can write about satellite programs of ISRO, and there you can mention communication satellites, give few examples like GSAT or CMS. Second type of satellites, mention about navigational satellites. There you can talk about Gagan and Navik. Third, you can talk about remote sensing satellite. There you can talk about what ISRO has done till now. I'm not going into a lot of details about each of these satellites and their applications. I'm mentioning their name and I'm writing down 1 or 2 lines about them. That's it. Second sub bullet point within the first major bullet point will be rockets of ISRO. We will start with that how we started with this very small rocket called SLV with capacity of 40 kg. And now we have capacity of 4000 kg into GTO and 8000 kg into LEO with LVM3. Mention about SSLV also, mention about PSLV also. You can write a line about PSLV, one of the most successful rocket in the world, one of the most reliable one also. You can write about LVM3, heavy rocket of ISRO can launch payload agar capacity. If you can remember that, write it down. You can also mention about SSLV. But again, for all of these rockets, not more than 1 or 2 line. Third part, write down some of the most outstanding missions ISRO has achieved in space sciences. Jaise write down lunar mission, one heading lunar mission. Mention the success of Chandrayaan 1, talk about the partial failure of Chandrayaan 2, but definitely elaborate more, 2-3 more points about Chandrayaan 3, that India became the 4th country to successfully land and the first country to do that on South Pole. So, सबसे outstanding bullet points hai, mention that. Write about MOM, Mars Orbiter Mission. Talk about its cost effectiveness and talk about the fact that India was the first country, ISRO was the first agency to do that in its very first attempt. You can also mention about AstroSat, you can mention about Aditya L1 mission in one line. But again, we do not have to elaborate here. Then come to the second part of the answer, that how does space technology contribute to socio-economic development? So why I asked you that you need to rectify some of the points. Socio-economic development has a very specific meaning. We are talking about economic growth, but nonetheless, we are talking about social empowerment here. So type of growth which helps perhaps the poorest section of the society or the vulnerable section of society, we are talking about that type of growth. And for that, we need education, we need healthcare, we need good infrastructure, we need disaster management, we need forest resources, we need water resources. And then once you have in mind that for socio-economic development, which areas I have to focus upon, then think about that how different type of satellites can play an important role in a particular area. Jaise, how satellites will help in agriculture. Mention about how we can do precision agriculture with the help of remote sensing satellite, and how we can communicate to farmers on the right time about weather or about type of prices also, that which crop should be invested more into. Write about how communication satellites help in education, how communication satellites help in healthcare. Talk about how we use both remote sensing and navigational satellite, let's say in road construction. That plays a very important role in socio-economic growth. Financial inclusion, all of those things in banking operations. Then write about how these satellites play a role in disaster management. So few things which you have to avoid in the socio-economic development part. Do not have to mention about national security. Do not have to mention about our foreign exchange reserve. These points you do not have to write. But points about water conservation, forest conservation, agriculture, education, healthcare, all of that you definitely have to write whenever there is a question about socio-economic development. And accordingly you can conclude your answer. Again, this question is not an opinion-based question per se. So you do not have to write a very specific opinionated conclusion. It will be a simple general conclusion. So this is the first homework. Try to write down this answer at your home, and you can give your answer to me after the class, tomorrow class, not today's class, tomorrow's class or next class jab bhi hamari ho. And I will give you even more suggestions on your precise answer, that how can it be improved, right? So this is a homework I'm giving it to you for mains examination. Let's take a break here. We will talk about Aditya L1 mission after the break. How to send answer for online students? You can send me a mail. Scan your answer and send it to me. Give the next heading Aditya L1 mission. There is a question that while traveling in geotransfer orbit, it will enter into other satellites' orbit. Why would you assume that? Geotransfer orbit can be 1,000 types of geotransfer orbits. Won't there be any collision? No, there will not be, because we know about presence of other satellites, and space is really huge, which I was talking about in the last class also. There are two words here, Aditya L1. Both of these words have their own specific meaning. So I will come to the L1 word later, but first let me explain about Aditya mission itself. As the name suggests, it is a solar mission of ISRO, and in fact, It is the first dedicated solar observatory launched by ISRO. Why solar observatory? What do we aim to know more about sun? So this is what I want to focus first upon, and then I'm going to talk about the L1 part. What is this L1 means Lagrangian point 1. So what is that Lagrangian point 1 here? But why solar mission? We know that without sun, we cannot imagine life on this planet. And we also know more or less lot of things which we receive from sun. Of course, we receive sunlight. We receive sunlight into ultraviolet light. We receive sunlight into visible light. And we receive sunlight. Most of the sunlight actually is infrared, which we cannot see. But most of the sunlight is infrared light. We know that part. And that visible light and that infrared light plays a very important role that life is possible on this planet. But there are a lot of things about sun which we do not understand. We have some basic understanding. We know that sun also has many layers. We know about that. That the same way Earth has many layers, Earth has many layers, even sun has many layers. Very similar to Earth, even sun has a core. The difference is that we think of Earth's core as the hottest region of planet Earth. It is, by the way, 6000 degrees Celsius. But that is the coldest region on sun. Sun का जो surface है उसका average temperature 6000 degree Celsius है. 5700 degrees Celsius. I am approximating that to be 6000 degrees Celsius. And that is the coldest region on Earth. Cold and hot has no meaning if we are not comparing with some other thing. So the core of the sun, their temperature is about 15 to 20 million degrees Celsius. At such high temperature, you have a process going on which is called nuclear fusion. I'll be talking about nuclear fusion in more detail in the very next topic, nuclear technology. But in nuclear fusion, you have hydrogen nuclei coming together, fusing with each other and forming helium. And in this process, huge amount of energy is released. So the entire source of the energy of sun is that nuclear fusion which is going inside the core of sun. Think of this like as a chimney, and that chimney is producing a lot of energy. But then there are many more layers. You have convective zone, you have radiative zone. I am interested in or Aditya L1 mission is interested in the 3 outermost layer of sun. So what are the 3 outermost layer of sun? The surface of sun which you see, that surface is called photosphere. This we can see with our naked eyes, never do that although, for very long. But nonetheless, we can look at photosphere, the outermost surface of the sun. Turns out that there is a irregular layer beyond photosphere, around photosphere. This irregular layer is called chromosphere. Chromosphere, we cannot see that with our naked eyes. We can see that, however, with help of powerful telescopes, that there is this irregular layer called chromosphere. And then there is this amazing layer which we do not understand really well. We often call this solar atmosphere, but this outermost layer of sun, which is a very scanty region. Scanty in the sense that the particle density here is very less compared to photosphere, which is much more denser region. But it is a scanty region, but nonetheless, its temperature goes to 1.5 to 2 million degrees Celsius. So while the surface temperature is in the range of 5700 degrees Celsius, the temperature of corona is 1.5 to 2 million degrees Celsius. In fact, this is one of the first thing we want to further develop our understanding, that why is it so? We have some theories, but we want to confirm those theories and we want to understand this mechanism really well, that why is it happening. So the very first objective of Aditya L1 mission is that let's observe the 3 layers, the 3 outer layers of sun, photosphere, chromosphere and corona. We call it corona because it looks like a crown. Corona is a Latin word which means crown, that you have a crown-like structure around sun. The same reason why we call coronavirus as coronavirus. That coronavirus ka agar aap structure dekhoge, it has those spike proteins around it and it is called coronavirus. So solar corona is the outermost layer of sun, and also one area where we want to know more about the events which happen in solar corona. Sun is a dynamic planet A lot of things happen on the surface and on the corona, which we do not understand really well. And there are few things I want to highlight here. The first thing, you will come across this term a lot in newspapers. There is a term which is used called solar wind. Then there is a term called solar flare. Then there you will also come across a term called coronal mass ejection. There is not so popular, but nonetheless another term called solar prominence. Then you'll come across a term called sunspots. You'll come across a term called coronal holes. A related term is geomagnetic storm. So there are so many things Aditya L1 mission is trying to know about. The first three terms, they are often used interchangeably, particularly the second and third term. जो solar flare है और जो coronal mass ejection है, people often use them interchangeably, but they are two separate phenomena. The only common factor here is that most of the time they emerge together. Most of the time they happen together. But these are two different things and they have two different type of impact on planet Earth. Not everything which is emanating from sun is helpful to us. A lot of that thing can cause some damage also. We already know about ultraviolet light. We know that ultraviolet light is filtered out by ozone layer. पढ़ रखा है आपने. That is light. Thankfully, most of that ultraviolet light does not reach to the lower atmosphere. But there are many more things which are emanated by sun, and Earth can be affected by those things, and Earth gets affected by those things. So let's start with the first term, solar wind. What is solar wind? When we use the word solar wind, we are essentially talking about charged and magnetized particles. We are not talking about light. Light travels with speed of light. It is an electromagnetic wave. One light which we can see, we call it visible light, but there are many other type of light, ultraviolet light or infrared light. So solar wind is not light, solar wind is particles, and essentially these are electrons and protons. So most of the solar wind is electrons and protons, and all the time or from time to time they will be emanating from sun, and a part of that solar wind will reach to the earth also. Solar flare is light. Solar flare is light but very bright light. And this light has so much of energy that explode 1000 atomic bombs on earth together, and solar flare is brighter than that. So solar flare jo hai, that essentially is light. Most of that is X-ray light, ultraviolet light, but some is also visible light. So if we want to observe them, then we ideally need some sort of X-ray instrument, an instrument which can observe X-ray light or ultraviolet light. Yes, it can be visible light also, it can be infrared light also, but most of that is X-ray or UV light. A very high intense light. And just to give you some context of the size of solar flare, this particular picture, it's solar flare, the type of light which you see. And compared to solar flare, Earth is given to the scale. So that small object which you see, that is Earth here. So solar flare, we cannot imagine the intensity of solar flare. We can observe it from very far away, thankfully from very far away, because if we had been very closer, it would have incinerated Earth. Thankfully, we are very far away. But nonetheless, we know how intense it is, even from very far away. And that is why I made a statement that think of 1000 atomic bombs being exploded together, and think of that brightness. Solar flare is more bright than that. And compared to solar flare, Earth is a very small, a very powerful solar flare. Earth is a very small object. So there are places, particularly on photosphere, where you find this phenomena called solar flare. But solar flare essentially is light. Light travels with 3 lakh km per second. So solar flare we can immediately observe. Not with our naked eyes, because it is going to happen at a very specific location somewhere on sun. We cannot see that with our naked eyes, but we do have really good optical instruments even on Earth, and we do have observatories. Aditya L1 is of course a new addition to it, but there are many more observatories in space, particularly of NASA or European Space Agency, that they can observe those solar flares from very far away. So solar flare essentially is light, but much more intense light. The amount of intensity we cannot even imagine. This is going to reach in 8 minutes. That is how much time it takes for sunlight to come to Earth in 8 minutes. This often occurs on photosphere, on the outermost layer. Why does it occur? We frankly do not know. We have a very good theory that why does it occur. But even with that theory, we cannot predict when is it going to occur. Remember, good scientific theories should be able to predict things. We cannot predict solar flare. When is it going to happen? Where is it going to happen? We cannot predict it. We can give some estimation, but that will not be very accurate prediction. And why does it happen? The exact mechanism we do not understand really well. So to understand it really well, we need more and more amount of data. So there is a phenomena called solar flare, which essentially is light. Solar wind essentially is particles. We are talking about electrons and protons. And solar wind is a much more common phenomena compared to solar flare, which is a rare phenomena. Solar wind will occur with more frequency. Solar flare will be a very rare phenomena. But then there is one more phenomena which we should know about. With the help of powerful instruments on Earth or even in space, it looks something like this. And this event is called coronal mass ejection. As the name suggests, it happens from corona, not on photosphere, but it happens on corona. Coronal mass ejection. So now we are talking about, again, we are talking about particles. We are not talking about light, we are talking about electrons and protons, but not the electrons and protons of solar wind. Solar wind का जो energy है, जो particle concentration है, जो intensity है, वो बहुत कम है. जो solar coronal mass ejection का जो intensity है, बहुत ज़्यादा है. So both solar flare and coronal mass ejection happen together most of the time. Does not have to, but most of the time they happen together. And I often ask you to imagine it like this. Imagine a cannonball, top. Imagine a cannonball. Cannonball is powered by barud, gunpowder. So think of burning of gunpowder. And that burning of gunpowder will produce a lot of light, of course. But because of that energy, the cannonball will be released in a very specific direction. So while solar flare will be visible in 8 minutes, after solar flare, an event is going to happen which will expel millions of tons of plasma. Plasma is fourth state of matter when matter exists in ionized state. So till now we have studied about solid, liquid, gas, right? As temperature increases, solid becomes liquid, liquid becomes gas. Turns out that if I keep increasing the temperature, then those gases start becoming into plasma. Plasma is a state of matter where electrons gain so much of energy that they come out of the atom. And if electrons have come out of the atom, then whatever is left is positively charged particle, and electrons are negatively charged particle. So these positively charged and negatively charged particles now coexist together, but not inside an atom. So plasma is a very unique state of matter which exists at temperature of 1,000 or millions of degrees Celsius. And when you think about it, that most of the matter which we can see in this universe is nothing but stars and galaxies, जिनका temperature इतना ज़्यादा है that most of the universe or most of the universe which we see is nothing but plasma. So in our day-to-day life, we do not come across plasma, but most of the universe actually is plasma. So when I use the word coronal mass ejection, then I'm talking about millions of tons of plasma, which essentially is electrons or protons, hydrogen ions or helium ions, and millions of tons of them ejected into a very specific direction. So while solar flare will become very visible very early, 8 minutes, but as those particles get ejected, they will travel with very high speed, but of course they cannot travel with speed of light. Only light can travel with speed of light. Anything which has mass cannot travel with speed of light. So it will take few hours, 10, 12, even 20, 30 hours, but it is going to take few hours before coronal mass ejection can reach to Earth. Now it will be quite unfortunate for us. Sun is very huge. Coronal mass ejection can occur anywhere on Sun. and Earth is revolving around Sun. So it would be quite unfortunate for us that if the entire concentration of coronal mass ejection reaches to Earth the moment it is perfectly aligned, Sun and Earth are perfectly aligned. The probability of that event happening is very low. This probability of this event happening is as low as that I try to hit this pen with some very specific point. And I'm not a good shooter, by the way. So think of that, I try to throw something in a very specific direction. I'm trying to hit a particular target, maybe that fire alarm I am trying to hit from here with a very small point here. And I'm not a good shooter. So this probability is almost close to zero. I have to do that perhaps 1 million times and maybe I will hit it at one time. So coronal mass ejection का जो पूरा concentration है coming towards Earth, this probability is very less, but it is not zero. It can happen. Then what will be the impact of all of those phenomena? So I know that these three events do happen. Now what is solar prominence? Let me briefly explain solar prominence. I used the word solar prominence. You find on Sun an arc-like structure. That Sun के surface पे, photosphere पे, we find an arc-like structure. Energy, light in an arc-like structure. We know that it happens. We have no idea why does it happen. So solar prominence is a phenomena where on the surface of Sun, we find this arc-like structure, something like this. Of course, it will be much smaller than this, but you get the idea. We know it happens, we do not know why does it happen. So solar prominence is a very specific phenomena. But solar flare, coronal mass ejection, and even solar wind, they do have impact on Earth. It depends upon how powerful they are. And if Earth is unfortunate enough that it is in the line of path, when let's say all of that or perhaps thousands and millions of kg of plasma reached towards Earth. So what is going to happen when it reaches towards Earth? Turns out that Earth is a very good magnet also. हम सबने पढ़ रखा है ये चीज़? That Earth is a very good magnet. We have studied that in our school days also. Let me re-emphasize upon this point. That Earth has charged particles traveling inside the outer core particularly. Outer core is liquid. And inside outer core of Earth, you have charged particles moving around it. And whenever charged particles move, they cause magnetic field. So Earth has a very powerful magnetic field. Earth acts as a bar magnet. So that is why we often use this word North Pole and South Pole in case of magnetism of Earth also. So North Pole and South Pole is a geographic location. North Pole is that Arctic, South Pole is Antarctic. But when I use the word magnetic North Pole and magnetic South Pole, that does not have to be Arctic and Antarctic. That depends upon the nature of magnetic field. And turns out that magnetic North Pole and magnetic South Pole, they are not fixed. They keep on changing. Earth ka jo magnetic North Pole and South Pole hai, they keep on changing. In fact, the reverse also. After few million years, North Pole becomes South Pole becomes North Pole. That also happens. But nonetheless, Earth is a magnet. And that is actually quite beneficial for us. Because imagine all of those charged particles coming towards Earth. Earth has a magnetic field in space which extends to thousands and millions of kilometers in the sky. And that magnetic field will start repelling these particles. It will not allow those particles to enter inside Earth's atmosphere. From some places they can enter, particularly from polar areas they can enter. So most of the particles, they will be actually repelled back. And they can enter from polar areas. When that happens, when charged particles enter from polar areas, these charged particles interact with the upper atmosphere of Earth, and that interaction leads to production of beautiful colors of light in the sky. We call this light aurora. So you'll be taught about aurora again in geography classes, but I'm telling you here the cause of aurora. What is the causality of aurora? You go to North Pole or South Pole, you find this beautiful shimmer of light in the sky. People often pay a lot of money to witness these events. For example, you go to countries like Iceland or Norway, or even if you go to Antarctica, you'll find this beautiful shimmer of light in the sky, and that event is called aurora. So in any case, this interaction of solar particles with Earth's magnetic field, that interaction is called geomagnetic storm. Geo ka matlab Earth hai, magnetic ka matlab we are talking about Earth's magnetism, and how that Earth's magnetism interacts with solar particle, the impact of that we call geomagnetic storm. But remember, storms can be of very low intensity. अभी दिल्ली में 2 दिन पहले आंधी आई थी, थोड़ी देर के लिए आंधी हुआ, खत्म हो गया. So storms can exist for few minutes. Storms can be powerful, they can be weak also, but storms can be really, really powerful at some points of time. So geomagnetic storm can also be very powerful. So if geomagnetic storm is not that powerful, then it will cause, let's say, aurora. Beautiful event. People pay a lot of money to go to North Pole and South Pole just to witness this event in the sky. That entire sky, it looks like a disco is going on in the entire sky. But if that geomagnetic storm is very powerful, that is, if coronal mass ejection is very powerful, and Earth, unfortunately, is in the line of path of that coronal mass ejection, then more things will happen. That geomagnetic storm will not be limited to polar areas. We can find aurora even in higher latitudes. In fact, we can find aurora even around equator. That is also possible if Earth's magnetic field is not powerful enough to repel all of those particles. First thing. But even if it is more powerful, then what is going to happen? These electrical particles, magnetized particles, they will lead to a surge of electricity, first in the space itself. And because of that surge of electricity, जो हमारे satellites हैं, such as communication satellites or navigational satellites, their electronic circuitry will be adversely affected. So communication satellites and navigational satellites, they will not do their job really, really well if the geomagnetic storm is very, very powerful. Their circuitry will fry up and they will simply not function. If it is even more powerful, then a lot of those particles can enter inside Earth's atmosphere. And if particles are moving with very high speed, they will cause change in magnetic field causes an electrical field. So this will lead to a surge of electricity in our power grid lines. जो transformers हैं, जो electric poles हैं, and they are connected with these wires, suddenly you have lot of electrical current into this wire. And remember, आपके household में if there is a sudden surge of electricity, blackout happens, there is a fuse here which disrupts the connection. So same thing is going to happen, but on a much larger scale. That you have a sudden surge of electricity in your power transmission line, and because of that, lot of power transmission lines are simply going to fail. And that can lead to a blackout. But this blackout will not be a regional event. It can be a global event. That one part of hemisphere, one part of Earth's hemisphere is witnessing a significant blackout. That will be the most rarest phenomena. That will happen, which I told you, that this probability that all of the coronal mass ejection coming towards Earth and affecting Earth's geomagnetic storm is so powerful that it is disrupting our power transmission line. So understanding more about these things, that solar flares, why does it happen? Coronal mass ejection. Even solar flare can cause a lot of damage, by the way. Solar flares can give more energy to atmospheric particles, and that energy in itself can disrupt satellites. It can also change, in fact, they can cause some sort of air movement in the upper atmosphere, and that can change the orbit of satellites. That also happens. And their impact will not be as powerful as, let's say, a coronal mass ejection, but nonetheless, they can cause changes, particularly into upper atmosphere. A lot of times we use them interchangeably. Even UPSC has done it in past. UPSC has also done a mistake that they wanted to ask about coronal mass ejection, but they asked a question about solar flare. And they assumed that they both, this word, I'm going to show you a question here, by the way. And not that long ago, like 2-3 years ago, there was a question in UPSC examination. But these two are two different events with their own set of impact on Earth. So coronal mass ejection का impact है, वो बहुत ज़्यादा strong है, and it can cause, at its maximum damage, it can in fact cause blackout in half of the Earth. That is a possibility. So understanding about these events, knowing more about them, plays a very important role that we can adequately prepare ourselves for such type of future event. This is what Aditya mission is trying to do. That it aims to know more about photosphere, chromosphere, corona. It aims to know about those X-ray flares. It aims to know about those solar winds. It aims to know about that coronal mass ejection. Why corona is at such high temperature. All of those things it aims to know. So you can write down this first. Aditya L1 mission. Aditya L1 mission is the first dedicated solar observatory. Is the first dedicated solar observatory. Solar observatory launched by ISRO. Launched by ISRO. At Lagrangian point 1. At Lagrangian point 1. 1.5 million kilometer away from Earth. 1.5 million kilometer away from Earth towards the sun. Towards the sun. This mission has 7 scientific payloads. This mission has 7 scientific payloads. This mission had 7 scientific payloads. With following objectives. With following objectives. Write down in bullet points. The mission aimed to explore. The mission aimed to explore, or aims to explore. The mission aims to explore. Aims to explore outermost layers of sun. Outermost layers of sun. That is, in bracket you can write down photosphere, chromosphere. Photosphere, chromosphere. And solar corona. And solar corona. Write down the next bullet point. To understand origins of coronal mass ejection. To understand origins of solar mass ejection. Coronal mass ejection. To understand origins of coronal mass ejection. Next, to study the properties of solar wind. To study the properties of solar wind. Next, to monitor solar flares. To monitor solar flares. To measure the magnitude and nature of. To measure the magnitude and nature of. Nature of interplanetary magnetic field. To measure the magnitude and nature of interplanetary magnetic field. Interplanetary magnetic field. इसका simply मतलब ये है that as those particles travel throughout from Mercury to Venus, then towards Earth, what is the path they take and how strong they are, how strong they remain when they are traveling from one planet to another planet and finally reaching before Earth. So we aim to measure how intense they are and how that intensity varies as they travel larger and larger distances. So these are the objectives of Aditya L1 mission. Give the next heading solar wind. Let me make you write more about all of these events. Solar wind. A continuous stream of charged particles. A continuous stream of charged particles. Continuous stream of charged particles. In bracket you can write electrons, protons, electrons, protons, close the bracket, released from sun, released from sun. They mainly originate from corona. They mainly originate from corona. From locations called coronal hole. From locations called coronal hole. I'm going to explain this, don't worry. Write down the next point. Interaction of solar wind. Interaction of solar wind. Solar wind with Earth's magnetosphere. Interaction of solar wind with Earth's magnetosphere can cause geomagnetic storm. Can cause geomagnetic storm, which can lead to auroras, which can lead to auroras, can also affect satellites, and their orbits. A prolonged solar wind influences space environment around the Earth, and can potentially harm astronauts and spacecrafts. Can potentially harm astronauts and spacecraft. Can potentially harm astronauts and spacecraft. So solar wind most of the time is not a cause of concern. Sometimes it can be cause of concern, but most of the time it is not a cause of concern. Give the next heading, solar flare. Solar flare. It is a sudden and intense burst of energy. It is a sudden and intense bursts of energy. Intense burst of energy in UV light, visible light, and even in X-ray. Out of these three, X-ray will have the highest energy. Even in X-ray. They reach to Earth in 8 minutes, 8.3 minutes. They reach to Earth in 8.3 minutes. They can increase the energy of charged particles in Earth's outer atmosphere, affecting GPS satellites, communication satellites, affecting GPS satellites, communication satellites. Astronauts can be exposed to harmful radiation. Astronauts can be exposed to harmful radiation. इसमें एक लाइन और लिख लेना. They emerge from magnetically active regions on the sun. They emerge from magnetically active regions. I haven't defined a lot of keywords here. I'm going to define all of the keywords. Don't worry. Just write it down right now. They emerge from magnetically active regions from sun. Coronal mass ejection. Coronal mass ejection. Write down. It is a massive burst of plasma. It is a massive burst of plasma. Massive burst of plasma. ब्रैकेट में लिख सकते हो millions of tons of charged particles. Millions of tons of charged and magnetized particles. Charged and magnetized particles. It is often associated with solar flares. It is often associated with solar flares. Associated का मतलब both of these events can happen together. First solar flare, then coronal mass ejection. It is often associated with solar flare. It can induce a very powerful geomagnetic storm. It can induce a very powerful geomagnetic storm. Geomagnetic storm. Which can lead to write down in sub bullet points, auroral activity at lower latitudes. Auroral activity, so auroras at lower latitudes. Auroras at lower latitudes, so not necessarily 90 degree, but even at 60, 70 degree or even lower than that, can adversely affect satellites. Can adversely affect satellites. Adversely affect satellites and their operations. Next, can induce electric currents on the ground. Can induce electric currents in the lower atmosphere. Can induce electric currents in the lower atmosphere. Lower atmosphere. Adversely affecting power grids. Adversely affecting power grids. And without a doubt, can potentially harm astronauts. Can potentially harm astronauts. Let's define some of the words which I mentioned earlier. Start with geomagnetic storm. Write down in next paragraph. A geomagnetic storm is temporary disturbance of the Earth's magnetosphere caused by solar wind caused by solar wind or CME, coronal mass ejection, CME. And I already have told you that its impact will vary depending upon how powerful it is. Think of like a small wind or not very powerful wind, and think of a very powerful storm. So a very powerful geomagnetic storm means disruption of power grid. And even a weak geomagnetic storm means polar auroras, aurora australis and aurora borealis, which we talk about, which occurs at polar areas. But in between, there are many other things. Disruption of satellites, communication satellites, navigation satellites, changing the orbit of satellites, endangering astronauts being exposed to more radiation. All of that is not a good thing. So understanding more about this phenomena, that is very important. I also have used a word here, magnetically active region of sun and coronal hole. But to explain these two things, I need to tell you about two specific reasons, or two very special reasons on Earth. One type of reasons, we call them sunspots. So give this next heading, sunspots. We take a, let's say, visible light telescope, but it will most prominently be seen if I have an infrared telescope. So I take a visible light telescope that I am observing sun in visible light, or I'm observing sun in infrared light. And then you find that there are certain places on the surface of the sun, on the photosphere, not on corona, but on the photosphere. They will appear darker. Now why they are appearing darker, we know the reason. They are appearing darker because यहाँ पे जो temperature है वो कम है. कम का मतलब surrounding से कम है. कम का मतलब अभी भी temperature 3000-4000 degree Celsius है. So temperature still is 3000-4000 degree Celsius, but it is not 5700 degree Celsius. So temperature is less here, and because it is radiating less light, and hence it appears darker compared to the surrounding, which appears brighter. So why does it appear darker? Because temperature is less. Because of that, it is radiating less light compared to the surrounding. So while surrounding areas are brighter, this area appears to be darker. Then why does it happen? The best accepted theory here is that in this region, then we try to measure the magnetic activity of sun, and we find out that here magnetic activity is very high. The sun's magnetic field seems like intertwined here. Think of this, think of magnetic field like a rubber ball, and I have squeezed it. So यहाँ पे the magnetic field is so powerful that it is not allowing the internal particles, which have very high energy, to come on the surface. So think of now particles with energy in radiative zone and convective zone, inner layers of sun, which is not visible to us. But because of this very powerful magnetic field, think of this some sort of barrier, that it is not allowing that energy to come on the surface. And because of that, the surface energy in this region is actually not very high. The temperature is not very high. But from time to time, what happens? That this magnetic field realigns. I have squeezed a rubber ball and I remove my hand. So that is realignment of magnetic field. And suddenly, all of that built up energy at the lower inner layers of sun, it bursts out. And that bursting out leads to first solar flare, and then later from corona already has very high temperature, it leads to coronal mass ejection. So that is the meaning of this word, that you have sun's active, magnetically active region. They are nothing but sunspots. Now we do know that sunspots happen. Now there are few things about sunspot which we also know. They are not permanent. Just say in this picture I am looking at this sunspot. Keep looking at it, you will find that the sunspots are now disappearing, and some other place sunspots are appearing. So sunspots keep on appearing at different places on sun, and there will be a time where there will be lot of sunspots on the entire sun, and there will be a time where there will be very less sunspot. Again there will be lot of sunspot, and they follow a very nice cycle, that sunspots come to their minimum, then they reach to their maximum, and they again come to their minimum. So from one minimum to another minimum, or from one maximum to another maximum, it takes about 11 years. Why does it take 11 years? We have no idea. Why does sunspot appear randomly on sun? We have no idea. We do know its properties. We do not know why is it happening. What are the properties? Its temperature is less, its magnetic field is very high, but whenever that magnetic field realigns itself, it causes solar flare and coronal mass ejection. So understanding of that flare and CME perhaps will allow to better understand that why that sunspot activity occurs in a very nice cyclical periodic manner. This particular cycle is called solar cycle. You'll come across this term, sunspot cycle or solar cycle, which happens in 11 years. And by the way, we know about this cycle for last few hundred years now. ऐसा नहीं है that we figured it out in last like few decades. We have known it for past few decades, few centuries. In fact, at least 100, 150 years we have known that sun undergoes this solar cycle of 11 years, where sunspot activity increases and decreases. So how all of this will look like, there is a very good YouTube video available. I have given the link here on your portal. ये जो slides जो हैं आपके student portal पे, you can watch that, but I will give you a glimpse of some part of it. So this is the video. So you can think of first the layers of sun, and the core is at very high temperature, of course, where nuclear fusion is happening, producing energy. This will be a place where this place is magnetically very active. Because of that, it is not allowing particles to emerge on the surface with very high energy. But from time to time, the magnetic field realigns. And when that magnetic field realigns, a significant part of plasma breaks away. And this plasma has enough energy that it can overcome sun's gravitational pull. And by the way, sun is a very massive object. So think of now this plasma, which can overcome sun's gravitational pull. On telescopes, this event will look something like this, a very powerful event. And then it is going to travel to the interplanetary medium. Mercury, Venus, but it is going to reach to Earth. The good news for us is that Earth has a very powerful magnetic field because of all the charged particles in the outer core of Earth. And as these particles interact with Earth's magnetic field, the front of magnetic field is squeezed, the back is stretched. It's a very complex interaction. Most of the particles get repelled. Some particles can enter during day also, but day में aurora नहीं दिखेगा because sun is very bright. Other particles enter inside night, and that interaction we can see in the night sky, and that beautiful interaction which we call aurora, which occurs on both North Pole and South Pole. It will look something like this in the sky. The entire sky becomes brightened with this very beautiful shimmering color of light. But this is a result of geomagnetic storm. But same geomagnetic storm, when it is very powerful, then it can cause all other things which we have just discussed here. And all of that is because of sunspot. So give this heading sunspot and write down few things here. These areas appear as dark spots on sun's photosphere. These areas appear as dark spot on the sun's photosphere. These are regions of intense magnetic activity. These are regions of intense magnetic activity. Intense magnetic activity. Intense magnetic activity. They are cooler than surrounding areas. They are cooler than surrounding areas. They are cooler than surrounding areas. However, they are not permanent. They are not permanent. Sunspot activity occurs in a cyclical manner. Sunspot activity occurs in a cyclical manner. Occurs in a cyclical manner of 11 years. 11 years from one maxima to another maxima. From one maxima to another maxima. And similarly from one minima to another minima. From one maxima to another maxima. So sunspots, very intense sunspot at many places on sun, then a gradual decline, and then again very intense sunspot on many places of sun. So this one cycle happens in 11 years. This cycle is called solar cycle or sunspot cycle. So that is one of the things about sun we should know. The second thing which we should know is, give this heading coronal hole. I do not have a picture of coronal hole. You take a X-ray telescope, not visible light telescope. You take a X-ray telescope which can monitor the X-ray from sun, and you try to then look at the magnetic field of sun, particularly corona, and you find that there are certain places where magnetic field is often absent. There is almost like a hole in this magnetic field region, and this place is called coronal hole. And magnetic field, if it is almost absent, then all of those particles in the corona, they have enough energy and there is nothing to bound them, and they will emanate all the time. That is what solar wind is. So whenever coronal hole occurs, this leads to solar wind. So coronal hole does not occur on the photosphere. This occurs in corona. And coronal hole you cannot see in visible light. You can see that in X-ray telescope. If you use an X-ray telescope, you find this darker region which is called coronal hole. Write it down. These are regions in sun's corona. These are regions in sun's corona that appear darker, in extreme UV light and X-ray light, in extreme UV light and X-ray light. X-ray light. These are areas where sun's magnetic field is open to interplanetary space. Where sun's magnetic field is open to interplanetary space. Allowing hot materials from corona to escape. These are areas where sun's magnetic field is open to interplanetary space, allowing hot material from corona to escape. It is primary source of solar wind. It is primary source of solar wind. It is primary source of solar wind. Why I went into such detail in all of these topics? Because Aditya L1 mission aims to know about all of these things. And everything which I have discussed here was in newspaper. And I can expect a question from any of these themes. Even before Aditya L1 mission का जो plan है, that was envisaged, if I remember correctly, in 2017 only. There was a question asked by UPSC a few years ago. There is a question that why do I not smile? I don't think that is true, by the way. I do smile. You may have missed it. But that question made me smile. So anyways, there was a question asked by UPSC. क्या होगा आंसर यहाँ पे? I want more responses. Tsunamis could occur at equatorial regions. Tsunamis occur because of very intense earthquake in oceanic plate. Tsunamis cannot be triggered because of solar flare. So we do understand why tsunamis get triggered. Earthquake, and by the way, earthquake has to be very intense, only then tsunami occurs. And till now, we do not find any causality between forest fire and solar flare. So forest fire भी, that is also not correct, but बाकी सारे correct हैं. The GPS and navigation systems could fail, power grids could be damaged, intense auroras could occur over much of the earth, orbits of the satellite could be disturbed, shortwave radio communication of the aircraft flying over polar regions could be interrupted. All of those things are possible because of a very powerful coronal mass ejection. This is the question I was talking about. UPSC has used these two words together, solar storm and solar flare. They are not same. Solar storm is coronal mass ejection. Solar flare is that intense burst of light which we talked about in the class. Class khatam nahi hui hai. Why are you like wrapping up your notebook? The class is not over yet. So this is one part about Aditya L1 mission, that what it aims to achieve and what it aims to know about sun. And Aditya mission is not the only solar observatory. There are many more missions which has been launched in past by other agencies, but this is ISRO's first attempt to do that, and ISRO did it successfully. But where it achieved, or where this satellite or where this spacecraft is, that in itself is a huge deal. And I do not think that it is anywhere less successful than Chandrayaan 3. So Aditya L1 mission is not earthbound in earthbound orbit. It is not in LEO or MEO or HEO. It is in an orbit which is actually around sun, but it is also not completely sun-bound orbit. Earth is also playing some role into this orbit, and this is a very complex orbit which is called halo orbit, and it is situated at a point which is called Lagrangian point. Lagrangian point is one of the, again, most amazing things which you come across. So I'm not going to make you write anything, but I do want to give a introduction of Lagrangian point before I wrap up the class. I will not take more than 5 minutes of yours. Sir Isaac Newton, he discovered, or he knew about gravitational force, and because of him, all of us know about gravitational force. Sir Isaac Newton का जो theory है, when he combined his universal law of gravitation with his laws of motion, and with its simple ideas, he could now explain that why stars are moving or why even planets are moving. All of that thing is possible. There was a great mathematician and a great physicist also. His name was Lagrange. He lived few decades after Newton, almost 100 years after Newton. Newton lived in 18th century, Lagrange lived in mid of 19th century. So Lagrange was a great mathematician, and he had interest in lot of imaginary mathematical problems. So I told you that science is about how nature functions. We try to understand that, and the understanding allows us to develop various type of technology. So Lagrange was interested in a very specific type of problem, that, and he, by the way, had no idea that this problem which he was thinking about, it will find some utility in future. He had no idea that it is going to happen. He was just interested in mathematics. He wanted to solve an equation, and he did that successfully, by the way. So the equation he wanted to solve, जैसे मान लो in case of sun and earth, I assumed sun to be fixed and earth to be revolving around sun. This assumption is accurate, but it is not 100% accurate. The actual thing which happens is that both of them revolve around their common center of mass. There is something called center of mass we should know about. But if I calculate the sun and earth common center of mass, it will be very close to sun center itself. So I can easily assume that sun is at one point and earth is revolving around it. But now assume that this is a star. This is not earth. This is another star. Such systems are called binary star system. I have two stars in space, no planet. I'm only talking about two stars. And these two stars are not very far away from each other in a way that they both exert gravitational force upon each other. Now, can we assume that one star is fixed and another is revolving? We cannot. So in that case, they both are going to revolve around their common center of mass. As for example, if I assume this star has mass m, this star has mass m, then they both will revolve around a point which will be exactly in between them. So if this star is here, this star will be here. If this star is here, this will be here. So they both will revolve around their midpoint. But this is also not a difficult problem. Even Newton was clear what is going to happen in such case. This system is called binary star system. And we do find a lot of binary star systems in the universe. Even in Milky Way galaxy, there are millions of binary star systems. They themselves are quite interesting. Two stars revolving around each other at their common center of mass. But you can solve this problem also just by applying Newton's ideas. What Lagrange was interested in, that let's bring one more star. So I have two stars, or I have two very heavy objects. Let's call this object M1 and object M2. But let's bring a third object, M3. And then let's try to find out, because in the two case there was a mutual interaction, but now there is an interaction in this direction, there is interaction in this direction, and there is an interaction in this direction. Then how these bodies will move? Imagine three objects in space, only three objects. Fourth object will make things even more complicated. But imagine now these three objects, and now try to think about how they are going to revolve, or what type of orbit, if it will be orbit, what type of motion it will be. And it was very clear to Lagrange that this problem is so difficult that it cannot be solved. This problem is called three-body problem. And this problem is so difficult that you cannot solve it. There are so many possible solutions, and any of those solutions are possible. In fact, many of those solutions are possible together. You cannot actually precisely determine the orbit. Finally, one thing is going to happen. One of the object will collide with another, or another object will be ejected from the system, and it will finally convert into a two-body system. End result always and always will be a two-body system. But before it could become a two-body system, what type of motion will happen? We cannot determine that. To actually solve it, we need very, very powerful computers, supercomputers in fact, not even this computer. I need very powerful supercomputers to know that what type of motion is going to happen. And Lagrange, by the way, had no computer, forget about supercomputer. So Lagrange was clear 200 years ago that this problem is very difficult, we cannot solve it. And today also we know that this problem is very difficult. We cannot solve the precise solution. We can find approximate solution, and even then we need very powerful supercomputers for that. But Lagrange was then thinking that is there a special case? What if he assumed a special case of three-body problem? That what if I have three objects, M1, M2, but my third object, M3, is a very small object compared to M1 and M2. So M1 and M2 are very heavy, but M3 is very small. So M1 and M2, their mass is very, very large compared to M1, M2. So large that I can neglect M3. The same way I neglected Earth mass compared to Sun, or satellites mass compared to Earth. I am now talking about a third object whose mass I can neglect compared to M1 and M2. Then can I find a stable orbit for this M3, for this third smaller object? And to his surprise, he was able to solve this question. So he did not find a general solution of a three-body problem. He found a very specific solution of three-body problem under the assumption that the third object is very less massive compared to object 1 and object 2. And he then went on to solve it, and he showed mathematically, now we do not have to do this calculation, but what he showed is that if I have one object, let's say M1, I can assume that to be Sun. The other object, which is Earth, or I can take any two objects, it does not have to be sun or earth. And if I put a third object somewhere here, here, and at two perpendicular points from this straight line, that if I put a third object, and remember the assumption, the third object has to be very, very small compared to the two larger object. Then Lagrange successfully showed that at these 5 points, this third object will now find a stable orbit. It will not be unstable orbit. It will be a stable orbit. And remember, for every orbit, you need a centripetal force. Without centripetal force, you do not have orbit. But Lagrange showed that this centripetal force will not be because of only this or only this. It will be combined effect of both of them. So I have a three-body problem, a very specific type of three-body problem, where third body is very small compared to the first two bodies. And this third body can find a stable orbit around either these 5 points. These 5 points are called Lagrange points. And around these 5 points, the stability will be, or the required centripetal force, will not be just because of M1 or just because of M2. It will be the combined effect of M1 and M2. So I can find these 5 Lagrange points in Earth-Moon system also. I can find these 5 Lagrange points in Sun-Earth system also, or even in Sun-Jupiter system. So I can take any two larger objects. Now think of a spacecraft, a space mission such as Aditya mission. Aditya mission का mass कितना होगा? 2000 kg होगा. I don't know exactly what mass it has, but I'm assuming that let's say it is 2000 kg. 2000 kg compared to few billion kg, few trillion kg, and compared to few billion trillion kg, that is Sun, few trillion kg, that is Earth, and compared to that, what is Aditya L1? 2000 kg. So जो Lagrange का जो assumption है, that very much fits into this particular case, that I can send something in an orbit at L1 point, and I can find a stable orbit here, but this stability is not because of only Earth or only Sun. It is the combined effect of Sun-Earth system. But why are we doing that? Why are we not simply sending in an Earth-bound orbit? Why are we going to L1 point? I will answer all of that question in the next class. So let's wrap up today's class here only. Next class will also be last class of space technology. I will also start nuclear technology in the next class itself. And uske next class mein I am going to take a quiz of 25 questions from space technology in the class itself, in next to next class. So prepare well for that also.